Understanding the relationship between speed, distance, and time is crucial. The aeroplane problem, where you try to calculate the speed, distance, and time of flight using trigonometric ratios, is a very common exam-based question. These questions can either be asked as case study problems or as a long answer question. In this video, let's try and solve one such question. Let's get started. Hello everyone, welcome to LEAP, where you learn once and remember forever. For those who are watching LEAP videos for the first time, I am Deepika, a mathematics educator based in Melbourne, who tries to make math AEAP as easy as possible. Let's get into the video. Let's read the question first. The angle of elevation of an aeroplane from a point on the ground is 60 degrees. After a flight of 30 seconds, the angle of elevation becomes 30 degrees. If the aeroplane is flying at a constant height of 3000 root 3 meter, find the speed of the aeroplane. For these kind of questions, drawing the diagram is really important because it carries marks as well. So these icons that you see here, I'm going to use them to represent the position of the aeroplanes in my diagram. Reading the question again, the first sentence, it says, the angle of elevation of an aeroplane from a point on the ground is 60 degrees. So that means there is a ground level and there is an angle of elevation. What is the meaning of angle of elevation? So angle of elevation is formed when something is observed above the eye level of a person. So here, the point that we are talking about is on the ground. So above the ground, anything that is above the ground is going to be elevated. So it is going to cause an angle of elevation. All right, we will try to draw the ground level. So let's say this is your ground level. And let's mark the point as point A. Now, let's say your aeroplane is somewhere here, spotted somewhere here, and your line of sight of observing the aeroplane, let it be this. So they have mentioned that it is causing an angle of 60 degrees. So that means this angle is going to be 60 degrees. Now, continuing to read, after a flight of 30 seconds, the angle of elevation becomes 30 degrees. So you can see that the angle is reduced from 60 to 30, right? So that means it is going to fall lower than this 60 degree angle. This entire angle is 60. 30 will be somewhere in between these two, half of these two. The next thing that you have to check is if the aeroplane is flying higher or it is maintaining the same height. Only if you know that, you can continue to draw the diagram. So read further. If the aeroplane is flying at a constant height, so they have given that it is constant height, it is flying at a constant height. Let's try to put the aeroplane there. So it's maintaining the same height. So somewhere, let's say somewhere here. Now, from the same point, the angle of elevation, 30 degrees, as it says. So I'm going to mark that. I'm using another color so it's evident. So this is going to be 30 degrees. Now completing this figure, now we are done with the figure. Let's just complete it by labeling the vertices. Let's say this is B, C, and let's say this is D. And I'm trying to join this height as well. And let's take that as E. So the diagram is almost done. We just have to mention the constant height. So the height is given in the question, which is 3000 root 3 meter. So this is the height from the ground level. So that becomes 3000 root 3 meters. This as well is 3000 root 3 meters. Okay, both are height. And that's it. Now we can start with the problem. So we have to find the speed of the aeroplane. for that, we don't know how much distance the aeroplane has covered. So we just know that the aeroplane was at point D and then it moved to position C. But we don't know how much is the distance between D and C. Now, when I say distance between D and C, it is going to be the same as the distance between E and B. So we got to find this. Let's say that is X. And we also don't know what is AE. Let's say that is Y. So the first thing that I do is I have to mention in statement what are the things that are given in the question. So the constant height of the aeroplane equals 3000 root 3 meter. And I know the angle of elevation is 60 degree and 30 degree, right? So mention what is X and Y. Let AE equals Y and EB equals X. Whenever there is a height, that means it is perpendicular height. So you can see DE is height, that means it forms an angle 90 degree here. CB is height, again it forms a 90 degree there. So you can see there are two right angle triangles. Taking one triangle at a time, let's try to solve it. Let's begin with the small triangle. In triangle AED. So I'm taking the small triangle and I know the angle is 60 degree. So I will choose the sides which I need and which I know. So here I can see that I know the opposite side of this angle, which is DE, and I am supposed to calculate the unknown side Y. The unknown side Y is the adjacent side. Side DE, which is the height, is the opposite side. So that means I will use tan ratio. So tan is given by opposite divided by adjacent. So tan 60 degree equals DE over AE. So tan 60 degree, the value is root 3, and DE we already know that it is 3000 root 3, and AE we have taken it as 5. So as you simplify this, you transpose these two, we get Y equals 3000 root 3 over root 3. You cancel them, you get Y equals 3000 meters. So we have found the value of Y. You can take and mark this as first equation. Take the next triangle that you have. In triangle ABC. Again, you know the angle is 30 degree. The opposite side is the height, which is 3000 root 3 meters. And you know the entire distance that you have, which is the adjacent side, is basically your Y plus X. So let's do that. So again, we go with tan ratio. You get tan 30 degrees equals, you know, the height, which is 3000 root 3. And you know the base, which is your adjacent side, is Y plus X. You know tan 30 degree is 1 over root 3 equals 3000 root 3 divided by, you know, Y is 3000, so 3000 plus X. Now you can do the cross multiplication method and you get 3000 plus X equals root 3 times root 3 is 3. So when you multiply root 3 times root 3, it is 3. 3 times 3000 is 9000. Now as you transpose this 3000 there, you get 9000 minus 3000, which is 6000 meters. So now you know both the distances. So as you substitute it here, you can mention it is from 1. So we have found the value of Y and X, which is the entire distance that you have got. And now we have to find the speed of the aeroplane. So speed, the relation between speed, distance and time is speed is equal to distance over time. So here we are supposed to calculate the speed. So if you know distance and time, calculating speed is very easy. Here they have mentioned that the time of flight is 30 seconds. Now this 30 seconds is for the flight to go from point D to point C. So time from D to C you know, and you also know the distance from D to C. So the distance traveled is basically x that you calculated as 6,000 meters. Don't take the entire distance because here the time given is only for the distance traveled from D to C. It's not from A to B. So do not include y. That is a very common mistake that students make. So the distance is from E to B and then the time is 30 seconds. So speed equals distance divided by time. So let's try to substitute here. Your distance here is basically the distance between E and B, which is x, and your time taken is given as 30 seconds. So this is in meters, this is in seconds. All right, remember that. Now, x is 6,000. So substituting 6,000, and you know the time is 30 seconds. So it is divided by 30. When I simplify this, I end up getting 3 times 1 and 3 times 2 is 6 and 200. So my answer is 200 meters per second. That is the speed of the aeroplane. So don't forget to write your concluding statement. Speed of the aeroplane equals 200 meter per second. That's it. I hope you were able to understand the solution now and are more confident in approaching these types of problems. Thank you so much for watching. If you like this video, please give a thumbs up and follow Leap to learn more and make math AEAP as easy as possible. Thank you.